Hi everybody. Today is September 2nd, 2.3 day 1. We're going to learn some properties of functions. All functions are either even, odd, or neither. Classifying functions as such can provide us with information about the graph of a function, including specific points. Definition. A function is even if for every number x in its domain, the number negative x is also in the domain, and f of the opposite of x equals f of x. When you have substitute in x, you get the same y value as when you substitute in negative x, or the opposite of x. So in an even function, for every point xy on the graph, the point negative xy is also on the graph. A function is even if and only if its graph is symmetric with respect to the, do you remember which one had xy and negative xy on the same graph? The y-axis. So if we had the point 3, 1, which is xy, and then over here we have negative 3, 1, the opposite of xy, then it's symmetric with respect to the y-axis, because the y-axis is the axis of symmetry right in the middle. A function is odd if for every number x in the domain, the number negative x is also in the domain, and f of the opposite of x is equal to the opposite of f of x. When you substitute negative x in, instead of getting an equivalent equation and having it be symmetric to the y-axis, you get the opposite equation, the exact opposite. So in an odd function, for every point xy in the graph, the point negative x, negative y is also on the graph. Both of them change. Do you remember which kind of symmetry it was when they both changed, negative x, negative y? That was when it's symmetric with respect to what? The origin. So if we had the point 1, 3, which is xy, then we go through the origin and end up on the other side, and it'd be negative 1, negative 3, negative x, negative y. And it'd be symmetric with respect to the origin. So by looking at the graphs, we're going to decide if these graphs are symmetric with respect to if they're odd, even, or neither. Okay? So this one, what kind of symmetry does it have? Y-axis, right? So that's even. How about this one? Is it symmetric with respect to the y-axis? It doesn't talk about the x-axis, because if you're symmetric with respect to the x-axis like this, then it doesn't pass the vertical line test, and it's not a function at all. So that's why it doesn't talk about the x-axis. This one, this point goes to this point if you go through the what? This point goes to this point if you go through the origin. So it's symmetric with respect to the origin. So this one's odd, and this one's neither, because it has no symmetry. So the test, besides looking at the graph, is substituting negative x to decide. We're going to determine algebraically by substituting negative x, not by just looking at the graph. And then we're going to graph them. So we do f of negative x, or the opposite of x, is the opposite of x squared minus 5. When you square an even, we have an even exponent, it's positive. And these are the same. It's equal to f of x. If it's equal to f of x, since f of negative x equals f of x, the function is even and the graph is symmetric with respect to the y-axis. Yes, you write all of that. So if we're going to graph a parabola, because it's x squared, what does a negative 5 do to the parabola? How does it move it? Down 5. So it is symmetric with respect to the y-axis. This one, we do g of negative x equals negative x quantity cubed minus 1. Don't forget your parentheses. When you have it cubed, an odd exponent, it's negative x minus 1. Is that the same as g of x? No, there's a negative. If you take out a negative, then it's x cubed plus 1, which is not equal to negative g of x. Because the opposite of g of x would be negative x cubed minus 1. And this is not the same as that. So it's not equal to the opposite of g of x or g of x. Since g of negative x is not equal to g of x, they're not the same. And g of negative x is not equal to the opposite of g of x, the function is neither odd nor even. The graph has no symmetry. It's a cubic, and what does the 1 do to it? This is x cubed, which does have symmetry about the origin, but what does the minus 1 do? It moves it how? Down 1, and then it doesn't have any symmetry anymore. H of negative x equals 5 times negative x cubed minus negative x. Don't forget your parentheses when you substitute in the opposite of x. Negative 5x cubed plus x. If you take out a negative, that's 5x cubed minus x. That's h of x, right? So that's equal to the opposite of h of x. Since h of negative x equals the opposite of h of x, the function is odd and the graph is symmetric with respect to the origin. if it's equal to the opposite of x. If it's equal to the same function, then it's the y-axis. And then this one, f of negative x equals absolute value of negative x, which is, you can take out the negative 1, and you get just absolute value of x. The absolute value of the opposite x and the absolute value of x are the same. Absolute value of 6 is 6. The absolute value of negative 6 is also 6. So they're equal. Since f of negative x equals f of x, the function is odd or even, and the graph is symmetric with respect to what? It's even, so it's the y-axis. And you should know how to graph absolute value. It's a v with the slope of 1 and negative 1. So the last thing we're going to learn about is increasing and decreasing. A function, the definitions are kind of confusing, but increasing is when from left to right it goes up, and decreasing is when from left to right it goes down, and constant is when it stays the same. But it says a function f is increasing in an open interval I for any choice, if for any choice of x1 and x2 in I, if x1 is less than x2, then f of x1 is also less than f of x2. So if we have an open interval I, and we pick an x1 that's less than x2, then when we do the y value of x1, it'll be less than, it's down less than the y value of x2. Because it's increasing, it's going up from left to right. Function is decreasing in an open interval I if for any choice of x1 and x2 in I with x1 less than x2, f of x1 will be greater than f of x2. So if we have an open interval I, and we have x1 right here, so f of x1, and then we have an x2 right here, so this is f of x2, it's negative. F of x1 is greater than f of x2. Then it's decreasing, it's going down the roller coaster, and it's constant if in an interval any x you pick, whether it's x1 or x2, you get the same value, you get f of x. F of x is the same, it's constant with for all the choices of x, the value of f of x are equal. So f of x1 and f of x2, they're equal because it's constant, it's going straight across. So we're going to do an example on the second video.